Hi, good afternoon, everyone. Today we are happy to have our partner Arkessa. They work with us to empower our platform for IoT. We all know connectivity and security are crucial for IoT, and the solution from Arkessa can allow you to easily deploy this and scale up your IoT solution. Today we have Len from Arkessa to share with us more details about their solution and what they do with AAEON. Okay, Len, I will pass the ball to you.
Okay, good afternoon, everyone, and thank you very much to our friends and partners at AAEON for giving us this opportunity. So, as the introduction has said, we at Arkessa are a connectivity provider for industrial and enterprise IoT. And today we want to talk about what connectivity can do for IoT systems and from a deployment point of view, from a business point of view, but also and most importantly from a security point of view. And you can tell from the image on the right hand side that security is an important topic, and it's going to feature quite strongly today in the session. So okay, so the agenda for today are really just three sections. The first of which I will use to demonstrate how Arkessa works with AAEON, and we'll use some use cases to do that. We'll then talk a bit more about cellular technology for IoT and the security benefits that it brings, and then explain a bit more about the managed services that go around IoT connectivity and what they can do for solutions. And the whole point of the session today is really hopefully to prove to you that Arkessa does make cellular IoT-based solutions much easier to deploy and scale, and makes them more secure. Okay, so how do we work with AAEON? So I'm showing here a couple of screenshots from some marketing material, from marketing campaigns that we've developed around the AAEON Up Squared board. And what you're looking at actually are two data sheets from an Intel market-ready solution that we developed in partnership with AAEON and the Up Squared board and another partner called EUICC. So you'll recognize the image on the right-hand side there as an AAEON created product. And what EUICC have done there is to create an intelligent edge device, an IoT gateway, and what Arkessa do is add 4G into that that makes it much easier to deploy and commission and maintain when it's in the field. This is a program sponsored by Intel, of course, and we have a presence on the Intel Solutions directory, and there's the page and there's the link. Now, the reason I'm introducing the campaign, as you know, because it's important, and what we see here is the fact that Intel have built this campaign and are promoting these type of solutions because what we find in industry and in enterprise environments are that some of the larger companies certainly are starting to invest in Internet of Things solutions, but still they're identifying that they have some gaps in their capabilities and skills, and also that they perceive there are still some gaps in some of the solutions that are in the marketplace. That's something that Intel are helping to address with these campaigns that I've just described. So, but if we look though at some of these skills and capability gaps that this McKinsey report has identified, then large enterprises are still worried about how to extract data from the remote assets, from machines and from sensors. They're looking to create different business models. So by that we mean they're looking to evolve from purchasing hardware, purchasing software, purchasing components all separately, and integrating them themselves and commissioning themselves. And instead, what they're increasingly looking to do is to lease, to use an OPEX-based budget to lease hardware, to lease solutions rather, should I say, that they can quickly and easily deploy. And the third thing that I would highlight, and I'll just move my cursor to help with this, is that the other important element that enterprises are looking to their suppliers to solve is to make it much easier to integrate these IoT solutions and the data that are generated by these IoT solutions into existing business workflows. And then the big red image on the right-hand side mentions security. This has been for a long time and continues to be a big concern for large enterprises adopting Internet of Things technologies. So I hope that in the next few slides, I'm going to demonstrate how we've come together to work with the different partners that I mentioned, and that's AAEON, it's Intel, it's AAEConnect, and it's Arkessa, to help address some of these capability gaps. And just to demonstrate that it's quite real, I want to show you a couple of use cases where we've deployed into a couple of different business environments. and the images that you're looking at here are from a manufacturing environment, specifically a food process automation environment where where we enabled AAEConnect to deploy back-off industrial controllers, the intelligent edge device that we just had a glimpse at a moment ago, and use them to instrument these automation, all these production lines, and use machine learning technology to learn, to adjust the timing of these processes, and ultimately to minimize waste. And so we were able quite quickly here to prove to the manufacturers that there were savings to be made by deploying the technology. And when you get into that position, then it's much easier to scale the solution from that point once you've proven the technology and proven the value of the technology. And of course, the key value that Arkessa has brought to that is using a 3G or a 4G cellular connection to simplify the commissioning of that system in the manufacturing environment by enabling the secure cloud connectivity, which is independent of the local IT or OT constraints. We were not allowed to connect our equipment into the existing IT or OT networks. We had to find a way to get the data out of those environments without any local connectivity, and cellular was the preferred approach. And so the two images, of course, are showing food manufacturing and a bottling production, both fast-moving environments where any delays, any waste in the production line is costing the manufacturers money. So a real strong use case which we succeeded in demonstrated value from. The second environment is, as you'll recognise, is an office environment, and actually a very similar solution was deployed into this environment. Of course, the sensor technology was different. Some of the wireless technology we were using locally within the office was different than the manufacturing environment, but nonetheless, the intelligent edge device was connected on a 3G or 4G connection, and because of that was much more easily deployed and commissioned and maintained while it was in this case the building environment. And thinking of the business system integration, what we were able to do was to get the sensor data. So think in an office environment, you should be thinking here about things like desk occupancy, the heating, ventilation, lighting, air quality in office environments. And we were getting that sort of data out of the office and into, so in this case, some IBM systems. So Maximo is their asset management platform. Tririga is their facilities management platform. So there, here we have is is evidence of using edge devices, using the cellular technology, and getting the data securely and quickly out of the office environment and into the business systems of the customer. That's really important. Okay, so the solution then, if we look at it from a system diagram point of view, then this is probably quite familiar to many of you listening, in the sense that there is the edge device, the gateway, based on upsquare technology. Remember, the software, the services come from IAEON, and what they're doing is creating a device that aggregates the data from the different sensor types. In this case, I'm showing a building or office or warehouse environment, and those are the type of sensors that we have deployed. And then if you look towards the right-hand side, then the red arrows are showing that they're from the gateway. There's a secure cellular connection from the edge device to the cloud systems. And of course, we integrate with all of the major cloud service providers. You'll recognize the names: Azure, AWS, IBM, Google Cloud, and ThingWorx also. And all of these providers are, bringing machine learning and artificial intelligence and more to the Internet of Things. Services that can run on the edge devices as well as in the cloud. Now, if we look at the same, but this time look at it from a commercial point of view or a deployment point of view, not so much a system point of view, then there we go. The gateway was missing. Well, then what do we have? Well, we have an Arkessa SIM that gets embedded in the gateway on the production line in Taiwan in this case. And then we have the system or the gateway device which provisioned and then shipped directly to the customer site. Now with the cellular connection, if we look at the first yellow circle now, the cellular connection was enabling that faster deployment and the over-the-air fleet management of that gateway once it's in the field. And we can use the connectivity management controls that Arkessa provide to manage the cost, the data usage, and ultimately the security of that connection and that deployment. We'll say more about this in the next few minutes. And then finally, as we move towards the right-hand side, I want to remind you that what we're providing here with cellular is a secure cloud connectivity, a secure data ingest into the enterprise or cloud type environments. And ultimately what we've created is a mobility solution that's optimized for leasing or X as a service type business models, OpEx type business models, because it's cellular connected and doesn't rely on any local connection. It's secure. It can be deployed anywhere in the world. Can be redeployed anywhere in the world. So highly scalable, highly flexible type solution. And these are the kind of key values and the key building blocks that we've worked with AAEON and IAEON on, and of course with Intel to help create these market-ready solutions that satisfy some of those concerns that larger enterprises are having. We spoke about them earlier from McKinsey. Okay, so just a reminder about why cellular before we move on, and I'm not going to read out all the details just now, but there are three key reasons why cellular is important. And the first is the ability to deploy these solutions quickly. So rapid deployment for third-party provider solutions. So often in manufacturing and indeed any building environments, of course there is Wi-Fi, of course there are Ethernet connections, but these are typically deployed by and maintained by, controlled by IT departments, security teams, operational departments, and they often do not like third-party provider solutions to be connected into those solutions. Cellular cellular allows us to cut through that issue and much quicker, and while maintaining the security of the solution. I mentioned mobility already. We have a solution here that can now be deployed anywhere in the world, can be redeployed anywhere in the world, can be managed remotely, and that makes everything from the manufacturing processes, the logistics and distribution processes, the reverse logistics processes much easier. And then number 3 is secure private networking qualities of cellular. So all of us on this call will have no doubt a mobile phone, and we'll have a view of what mobile data and cellular data looks like. But actually what we have with the mobile phone is an internet connection. What you have with an M2M grade or an IoT grade managed service is the ability to create secure private networks. And that's important for enterprises in both industrial and commercial property landscapes. So let's say a bit more about mobile, a bit more about cellular. And if you think about your own personal cellular data experience, then it usually starts with a device like this, a smartphone. And it's worth remembering, of course, that with a smartphone, we use it more and more, and we use it for a lot of sensitive type applications and transactions, like mobile banking. And this is a slightly out of date number, but back at the end of 2017, there were already over 1 billion mobile banking users. So not just online banking, specifically mobile banking users. And these applications around mobile banking have expanded way beyond just smartphone apps. You can perform banking transactions and payment transactions from wearable devices, IoT devices, and even voice assistant solutions like the Amazon Echo, and of course there are many others besides Amazon. But we're using technology for secure, sensitive transactions every day now, or many of us are. The car or the vehicle that you use on a regular basis is another example of a connected solution. But this is also an example here, this article that we're looking at is also an example of where privacy concerns or mismanagement of data and access to data can go wrong. And what I mean by that is that this article was demonstrating that companies like Land Rover and BMW, Mercedes-Benz, Nissan, etc., we're all having issues with changes of ownership of vehicles. So someone, for example, a customer buys a car brand new, subscribes to the connected car services from the manufacturer, uses it for, let's say, 2 or 3 years or more, or less, but ultimately returns the car or sells the car. The problem was the data connection wasn't changing with that change of ownership, and they were finding that some of their customers were able to access a car that was ultimately owned by someone else. Now these problems have been solved, of course, and Arkessa's managed services could have solved these issues immediately had they been deployed. But the issue I'm sure you're getting at here, while it has been solved by these manufacturers, I'm not trying to worry you or scare you, is that there's a real concern about data and keeping it secure and making sure that only those that have the authority and ownership of data get access to it. It can quite easily go wrong. However, with Arkessa and our managed services, we can help make sure that that's not the case. So yeah, cellular IoT is fundamentally a secure technology. Of course, it's true that sometimes the devices or the endpoints or the cloud environments that we are connecting with cellular are not always secure. So keep that in mind. But if we look at cellular as a technology, it is fundamentally secure. And don't worry, we're not going to walk through every acronym or every technology reference that's on this slide. but it's just a reassurance that actually cellular does help companies secure the connection from their devices through the radio networks and the enterprise type environments and into the cloud if need be. And what you'll see in the diagram are, you know, icons representing firewall technologies, access control list, radius authentications, technologies like VPN and APN and IPsec and so forth. But if we simplify that image now, then essentially what I'm saying is something like this, that with cellular IoT, we can create secure private networks between devices and the enterprise cloud environment. And so the arrow that connects the device through the Arkessa network and into the enterprise cloud, that is a secure private connection. And we can do that by using services and technologies like fixed IP addressing and private IP addressing. So fixed IP addressing is important for Internet of Things solutions, because the devices have to be reached from the network, from the cloud side. So dynamic IP addresses change over time, and that makes it very difficult, if not impossible, to reach a device from the cloud environment. We use private IP addressing, so these are IP addresses that the internet equipment don't recognize, and so we can essentially isolate the devices and the data being generated from these devices from the internet. And we can use something called APN technologies to control access to these devices as well. So, as I said, what we're doing here is isolating the devices and the data from the internet. And in fact, the internet access is restricted, unless, of course, the application or the customer requires that internet connectivity is used. You can still, of course, use VPN and IPsec type technologies to secure that interface. But you keep in mind that you can isolate it completely. So secure private networking, and that creates these secure environments. And remember, this is important. So, you know, companies, many companies, you must have experienced it yourself, will worry about where their data is being stored. Is it on premises? Is it off premises? And is it really secure, or is it really private? And the answer is, it can be. It can be if you work with the right service provider, with the right type of services. Now, if we look slightly beyond security now, then, and think about Arkessa in a more holistic sense, then with this diagram, and specifically the yellow section of the diagram, give a broader view of Arkessa and the type of services that we provide. We've spoke a lot about security so far, and I want to widen it a bit now. So on the diagram, just to calibrate you, on the left-hand side, we have some icons that are representing the different type of sectors that we operate in. And you know, there are 8 icons there. Of course, there are many more applications and services that we support. But then if you look towards the right, we'll see a list of the different operator connections that we have, and in fact, the type of numbers you should be thinking about are 600 networks in around 200 countries. And what that means is that we can provide our customers access to up to 550, 600 mobile network operators in more or less anywhere in the world. And we can aggregate all of those connections, all of those data feeds into a single platform, and it can be, our customers can manage from there and secure their data from there. So the type of services that Arkessa provides, so in yellow, are of course, we're talking about cellular, and of course that includes a SIM. And we have a range of products and services from global roaming SIMs up to the very latest cutting edge solutions around technologies like eSIM, which are essentially reprogrammable SIMs, and we'll say more about that as we go forward. So moving down the yellow stack, we've made the point already, what we're providing is global mobile network access. But as well as that, we're providing management services, so connectivity management. And that means what we're doing is giving our customers the ability to monitor when their devices are online, when they're offline, how much data has been transmitted, how much data has been received, and what does that look like versus the tariffs that they've signed up to. That's really important. You know, you can do a bit of diagnostics both on the technical side, on the connection side, but you can also use it as a commercial management tool to make sure you're not consuming too much data or even underusing data. So very powerful services that we bring. And then subscription management services. So you'll recognize already that, you know, we're providing access to many mobile network operators, and we can do that because we have the technical integrations, but also commercial relationships with them, and we can make sure we're providing their customers with the right subscriptions, the right profiles on the SIM cards and so forth. And remember, we can do that in an automated way now, thanks to eSIM and EUICC technologies. So we'll see a little bit more about EUICC as we go forward. And then the fifth block in the stack is security. We spoke about the security credentials up front, and we won't repeat them unless there's demand in the Q&A. And then finally, on the right-hand side of this diagram, we have a representation of the enterprise environment or the cloud environment. And we you know, as Arkessa as a company, we don't store our customers' data. What we're doing is switching or routing the data from their devices to their preferred enterprise environment. So that might be their own private enterprise data center. It might be a cloud service provider, or it might be, as I said earlier, it may actually be an internet connection. Okay, so a little bit more on the SIM technology. As I said earlier, we have a range of products and services from you know, global roaming or regional roaming, pan-European roaming, for example, solutions. So that's a single SIM that will connect anywhere in that region or anywhere in that world, and that's perfect for you know, those types of international deployments, and also perfect for lower data type applications. And one of the key benefits that we deliver with our global roaming solution is the non-steered approach that we take. So typically, when you buy a SIM card from a mobile network operator, there's some commercial bias. There's logic inside the SIM that tries to enforce the SIM to connect to its parent network or its preferred partner network. And that's not always the right thing to do, of course, if there's not good coverage in that situation. And so what we do is remove any of that steering and create this non-steered solution that allows the device to connect to the right network for that geography, or the right network for that application. Now, the latest, greatest technology in our industry are reprogrammable SIMs, eSIMs, if you like, or more specifically EUICC. eSIM is a reference to a hardware form factor, but EUICC is essentially a software capability, a SIM-OS capability that allows it to be reprogrammed over the air. Okay, we'll say more about that in a minute. But first of all, it's worthwhile having a quick look at the evolution of the SIM technology from a form factor point of view. Now, depending on what age you are, you may or may not remember SIM cards looking like the image on the left-hand side here, an ID card size. That's ancient history now, it has to be said, and these days what we typically see are one of these three form factors, which, you know, the standards refer to as 2FF, 3FF, 4FF, or mini SIM, micro SIM, nano SIM, and you can see them getting incrementally smaller. Now, in the semiconductor supply chains, of course, what we're increasingly looking at are eSIM technologies. We call it MFF2. But eSIM, so it's a 6x5mm chip form factor. And what will come soon is a 2x1mm chip level solution. Still an eSIM, but you can see it's a much smaller package approach has been taken. So the two images on the right hand side here are eSIM technologies, and the images on the left hand side are traditional plastic or removable SIM cards. Now, actually, the EUICC solution, remote provisioning capability, applies to everything that you see here. So you shouldn't confuse eSIM with the EUICC. Now, it's worthwhile noting, however, of course, that both of these eSIM form factors are electronic components that are going to be soldered down onto a circuit board. They're going to be conformally coated and enclosed in a piece of plastic or whatever. And so at that stage, it's almost impossible then to be removing a SIM. So the remote provisioning tools and services that the GSMA standards have defined and Arkessa's platform supports are really essential. But they're not unique to those form factors. They do apply to the SIM card technology. Okay, this is a slide I've included just for reference, actually, which you can look at later. I've covered everything on it. I meant to hide it, but just a couple of words while we're here. Remote SIM provisioning, and I just said, is critical for the embedded SIM solutions, the eSIM solutions. It is a GSMA standards, and as it says there in that first paragraph, the specification allows enterprises to remotely change and activate the SIM profiles on IoT devices. It's worthwhile noting also that there are consumer standards as well as M2M or industrial standards, and they're a bit different, but they are both essentially providing that remote provisioning capability. Okay, let's just spell out a little bit of what EUICC actually provides. And then we'll talk about the benefits that enables in the embedded space for IoT devices, for IoT gateways, and so forth. So there are 5 key messages, and you can see the 5 black dots numbered 1 to 5, and the notes along the bottom correlate with each one of them. And number 1, so first of all, it's worthwhile just, as a reminder, that EUICC is a SIM operating system capability or a software capability that essentially allows the EUICC to host multiple SIM profiles. Now, there will always be a default or a bootstrap profile present initially, but that can be added to or it can be changed. So number 1, multiple SIM profiles. And number 2, what typically happens when an IoT device powers up is that the device will use the default or bootstrap profile to connect to typically a network on a roaming basis. And that provides that default connection wherever it is in the world and allows it to connect to a subscription management service, which is something Arkessa provide. And what the subscription management service was then able to do in a predefined and automated way is to determine what should happen to that IoT device and how it should connect in future. And so it might, typically what we'll do is work with our customers to define a set of rules, a set of logic that would say something like, the IoT device has connected in Germany and it's a metering application, for example. And so in that case, the business logic might say, it's a low data application. We've got a good commercial tariff in Germany. Let's just stick with the default roaming profile. Alternatively, it might say, I've landed in China and I am a different type of application. I'm a connected vehicle application. And so there are a few different parameters then in the business logic. It might say, well, I'm a high data, it's a high data application. I really want to connect on a different local tariff to take advantage of different commercials. It might also, the business logic might also say that there are different regulations in that part of the world. So there's another reason we should connect using a different profile and on a local network. And this can also all be pre-programmed and automated. It's really powerful, and it simplifies the logistics for anyone manufacturing and deploying and then operating solutions anywhere in the world. Very, very powerful. Now, in this scenario, of course, we've assumed that in step 3, the business logic has determined that a new profile should be downloaded. And that can happen. And then, of course, we have to activate that profile and switch to that profile. And all that happens under the control of the subscription management service. And at that point, of course, we then have number 4, we then have a local connection through the Arkessa infrastructure and ultimately into a cloud or enterprise environment of the customer's choosing. Now, number 5 really is just a reference to the fact that actually this process can repeat. So as a device is moving perhaps across different parts of the world, as ownership of that device, you'll remember the automotive connected car example I spoke about earlier, where there's a change in ownership. So the same thing can happen here. As there's a change in ownership in a vehicle, we can actively select and download new profiles, either automated or under the control of some business logic. Really simplifies the whole go-to-market process, forward logistics and reverse logistics processes for IoT devices. That was subscription management around EUICC we've just covered. It's also worth talking about connectivity management. And as I said a few slides ago, the connectivity management platform that we provide was essentially a secure web application that can either be accessed through a browser, or indeed integrated into your own or into your customer's device management platform, let's say, or fleet management platform. And what connectivity management provides is the ability to assess or monitor data usage at a glance and in near real time. So remember, it's identifying when devices are online or offline, how much data has been transmitted, how much received, which location or which network or territory is the device deployed in, and what network is it connected to. We can also use the management platform to set up alerts when certain data thresholds have been reached, for example. You can even cap the data usage on devices if you were worried perhaps about misuse of a device or overuse of a device or things like that. As I've just touched on, you can use it to help identify rogue device activity. You can certainly set the platform up to detect when a SIM has been redeployed in a different device, for example. And sometimes that might be okay, other times not. And so we can set up triggers in our platform that will detect when the SIM identifier is being used in association with a different hardware identifier, and that's quite a powerful feature. Ultimately, you can use the platform to suspend or terminate connections. If customers aren't paying for the services, for example, ultimately you can cut them off. Or if you have detected misuse or rogue device activity, you can terminate the connections. So you're also providing a layer of management, but also security in the solution. Okay, so we spoke about the type of work that we do with AAEON, the type of solutions we're building, through partnering, we're creating these secure, integrated solutions that include sensors, include edge gateways and intelligent edge application software, secure cloud connectivity. And it's these type of end-to-end solutions that, remember, are addressing those 5 or 6 enterprise capability and skills gaps that we spoke about. But cellular, is also evolving. We spoke a little bit about the SIM card evolving in terms of form factor and in terms of the management and the managed services that go around the SIM. But the cellular landscape is also evolving. And just on the top left here, there's a list of technologies that 2G and 3G will all recognise. Likewise for 4G and LTE. But these days we have newer technologies that are still cellular, but newer technologies like narrowband IoT, or as I've called it here, LTE Cat MB1, or LTE Cat M1, sometimes called LTE-M, and then of course 5G. Eventually we will have 5G. So all of these are cellular technologies, and at this point in time, they all have strengths and weaknesses, and they're more suited for certain type of applications than others, perhaps. But as the cellular technology landscape evolves, essentially what we're working towards is certainly one family of technologies for all industries. Perhaps with 5G, we'll have a single network that will work for all industries. But right now, that we don't have 5G, and so we have this other group of technologies that are more or less suitable for these different scenarios. So massive IoT scenarios are things like smart cities and metering and agricultural and environment type applications. And typically, of course, the key qualities required for those applications are lower cost and lower power. Typically there's lower data volumes associated with the devices, but of course they're deployed in a much more densely scenarios where for smart cities, of course, you're looking at hundreds of thousands, potentially up to 1 million devices being deployed per square kilometre, and these are the sort of parameters that LTE Cat MB1 and Cat M1 have been developed for. And then, of course, in the middle section, you have a bit more data intensive, higher data volumes associated with these type of applications like transportation and retail and hospitality, digital surveillance, and even drones that combine some of these different capabilities into those airborne form factors. So as I said, typically what we're thinking about here are higher data volumes, more real-time data streaming type applications. And right now, 4G is the best option for those type of applications. Now, out in time, towards the right-hand side of the slide now, and out in time, then what we're looking at the prospect of cellular being used for automation and safety critical type functions around autonomous vehicles, around the grid, smart grid. So thinking about load balancing and switching of grid segments. Robotics and machine vision, and indeed the process and factory automation scenarios we touched on already, and actually these are really going to be supported possibly by 5G, because what 5G offers is ultra reliability and low latency modes. It's able to create wireless time sensitive networking type environments. So traditionally, those have been industrial Ethernet technologies, wired technologies that have delivered that capability. The industry now is looking at 5G as a way to deliver that in a wireless sense. So really powerful, but slightly futuristic still at the moment. I think it'll be a couple of years yet before we can see 5G being used in that way. Now, there's a range of different network technologies we've just introduced really quickly just now, and what I want to do is spend the final few minutes of the call, and then I'll pause for questions, looking at the different values or different benefits of these different technologies. So if you look at that nice colourful matrix on the right-hand side of the slide, and and what you've got is the first column of the matrix is representing 2G or 3G, the second column 5G, the third column LTE-M, and then narrowband IoT. But the rows are in referencing some of the different, let's say, application requirements or deployment requirements that businesses typically have. And if you, I'm not going to walk through line by line, of course, on this call, but if you think about an application that requires either, it's either a mobile application, so like a vehicle, or it's been deployed internationally, it's been deployed globally, and you need extensive coverage, or you need access to multiple networks potentially, then actually in Europe, certainly today, 2G and 3G remains the best possible solution at the moment. And as opposed to, you know, the narrowband IoT type of solution today. And that's partly about the technologies themselves, but it's also partly about the fact that the roaming agreements that exist between operators across the continent or across the globe are much more mature and much more expansive on 2G and 3G than they are on narrowband IoT, where it doesn't actually exist at all just yet. That will come. Now, if you look further down the rows, and then we look at things like signal penetration and power efficiency, then that clearly, in that case, technology like narrowband IoT it's one of the key features that it was designed for, of course, has a clear advantage that compared to 2G and 3G and even 4G. So I think the key message is for the audience here and for your end customers is that when you're looking at cellular, you need to think, yes, about things like power consumption, of course, and cost, as always. However, you need to look at the cost element from a total cost of ownership point of view. You need to think about what the application is doing, where it's been deployed, is latency, data transit latency a concern, is security, what sort of security requirements are needed, and you've got to look at it much more holistically. Now, the good news, of course, is that Arkessa can deliver all of these services, and we can advise on all of these services. Now, albeit, of course, the narrowband and LTE-M technologies are fairly new and not fully deployed in every territory just yet. However, this is the type of thought process, design process that Arkessa can help our customers work their way through. So, a little bit complicated landscape. That's why we exist as Arkessa, to make that much more simple for our customers and for you in the audience. Okay, so just a final few words then in closing, and then I'll open for questions. So we've just touched on it, the cellular IoT landscape, the technologies are continuing to evolve to deliver lower power, to increase the signal penetration for indoor environments, also delivering higher bandwidth technologies. So we spoke about 4G as the current sort of high bandwidth technology today. Of course, there's also advanced LTE in the pipeline, and there's 5G in the pipeline. So not only delivering higher bandwidth, but also lower latencies, and opening up cellular as a technology that can be used in a whole range of different type of applications. Remember, from those massive high density, low data type of environments up to those automation and safety type of applications. The beauty of the cellular group of technologies that, from a security and from a deployment point of view, is consistent globally. Albeit commercially, you might be challenged if you go off shopping around mobile networks in different territories on your own. You'll find you'll spend a lot of time and have a lot of pain in contracting with with several operators at a time, and Arkessa can solve all of that. We can be your single provider for access anywhere in the world on all those different technologies. Now, thinking about the type of services and the type of applications, then with the third bullet, you know, we really are now starting to see technologies like machine learning and artificial intelligence and vision-based systems. So, you know, using local edge processing to do vision processing, or streaming of video data to the cloud for processing and archiving. These are becoming increasingly commonplace, enabled by the hardware technologies, of course, and the processing power that exists, but then also by the networking technologies and services that make them, you know, resilient, make it secure, make it globally deployable. And the final message, this is what I promised at the beginning, that I wanted to demonstrate to you, convince you, I hope, that Arkessa does make cellular IoT-based solutions much easier to deploy and scale globally. Okay, so that was my final message for the presentation piece, and we have maybe 5 to 10 minutes still available for any questions.
Yeah, thank you, Len. And everyone, if you have any question, you can fill it into the question and answer box. Then we'll help to answer all your question. Yeah. Then maybe we can wait for 1 more minute if there is no further question, and we can finish this webinar.
Okay, I don't think there are any questions
Yeah.
for now.
Okay.
I think, sorry.
Yeah, no problem.
I was just about to add that the plan is, I think, for AAEON to distribute the presentation, and along with my email address.
Mm-hmm.
So if you heard anything today that you want to follow up with more privately, let's say, then please do just send me an email, and we can pick up the conversation later.
Okay, no problem. We will share the slides of this presentation and the contact info of Arkessa, so that if there is any question from the audience and they want to know more about the Arkessa and the AAEON solution, they can contact through linking to Len and to AAEON as well. Yeah, and thank you, Len, for your presentation. Yeah, so that's it.
Okay, thank you very much, everyone.
Yeah.
Good afternoon.